Hello there, Mr. Sutton here, bringing you the first of two lessons on inverse trig functions. In this one, we'll find values of inverse sine, cosine, and tangent with and without a calculator, and we'll use this to help us figure out if a handicap ramp exceeds the maximum angle.
For a warm-up, here's a little thought experiment. Let's say I plugged an angle, theta, into sine, and it gave me a value of 0. What angle did I plug in? Where does sine of theta equal 0? Another way of asking the question is, what is inverse sine of 0? An inverse function, remember, takes the output and gives you back the input. So pause the video and ponder this for a moment. So if you think about this, there's actually a few places that you could take the sine of the angle and get 0. There's, of course, sine of 0 is 0, but also on the other end of the unit circle, sine of pi is 0. But I didn't specify any limits, so why stop there? Sine of 2 pi, I mean, that's really the same as sine of 0, but it is a different angle technically. So that's also 0, and we could do 3 pi and really any integer multiple of pi. Now this is a problem, because if we're only allowed to give one answer, which on a calculator, if you did this, you would only get one answer. I mean, which of these infinite numbers of answers do we choose? So the original trig functions, we notice, don't really have inverses. If you tell me the output, I don't know which input to give you, because for any x or y value or slope, you could just keep going around the unit circle and give me more and more answers. So because of this, we restrict the range of the inverse trig functions so that they only return half of the unit circle, and that way we only get one answer. So for example, inverse cosine, we're just going to give you the top half of the unit circle back. So whatever you plug in for your x value for inverse cosine, I'm going to give you back an answer that is between 0 and pi, or 180 degrees. For sine, inverse sine, we're only going to use the right half of the unit circle. So we're going to give you back an answer between negative 90, or negative pi over 2, and positive 90. And then for inverse tangent, same idea. We're only going to use the right half of the unit circle again, but this time it's a little bit different. We're going to give you a number between 90, negative 90, and positive 90, but not including those. Because if you think about it, you're plugging slopes into the inverse tan function. The output of tan is slope. The input of inverse tan is a slope. Up here, the slope you would be plugging in is a perfectly vertical slope, so it would be undefined. So inverse tangent can't actually give you back negative or positive 90 because the original function is undefined at those angles. But just the general summary, we're only using half the unit circle. Now, this is good news because it lets us actually output something on the calculator. We're going to see later on in the next chapter that this also gives us some limitations, but for now it's a good thing. Just a few more tidbits on our inverse trig functions before we use them. If you're wondering what these functions look like on the coordinate plane, here they are. Inverse cosine, inverse sine, inverse tangent. Now, by restricting their ranges, these pass the vertical line test. So the red part of these graphs is the actual function part. This other kind of faded dotted line, that's where the function would go if we did not restrict the output. So this would definitely fail the vertical line test if we didn't put that restriction on here. And remember, your calculator can only return angles in these ranges. Inverse cosine, 0 to 180. Inverse sine and tangent, 90 to negative 90, or vice versa. Now later on, you might see these functions referred to as arc functions. In calculus, that's what we call the inverse trig functions, or a lot of calculus teachers call them arc cosine, arc sine, and arc tangent. And that's exactly the same thing as what we're talking about here. It's not something new. Let's go ahead and use some inverse trig functions now. We'll start with a real-life application. The maximum slope allowed for a handicap access ramp to a normal building is 1 over 12. What angle is this? And we'll just round to the nearest tenth on this one. So the input now is a slope, and as our output, we want an angle. Whenever you're looking for an angle, you need an inverse trig function. So in this case, slope, remember, is tangent, so we want inverse tangent of 1 over 12. So if the tangent equals 1 over 12, if that's the slope, inverse tan of 1 over 12, we need to go to our calculator for this one. And don't forget to check your mode as you're doing this. We want an answer in degrees, so let's go to our calculator and make sure that our mode, Just get that arrow off. Our mode is degrees, and it is. Great. All right, so now to get the inverse trig functions, you're going to need to press the second or shift button and then the trig function that you want the inverse for. So on my graphing calculator here, here's the second button, and then we want inverse tan, so press the tan button, and now it gives us tan inverse, and then plug in your angle. In this case, we want 1 over 12. Enter. 4.7, 4.8. And now that since it's in degrees mode, we know that this is degrees. The calculator's not going to give you a degree symbol. You just have to know what kind of thing you're getting back here. So 4.8 degrees is what we're looking for a safe handicap ramp. So if you're feeling comfortable with inverse trig functions, go ahead and try these next two problems. In the first one, we want inverse trig for degrees for the sine function, and this last one we want the nearest hundredth of a radian, so be careful with your mode. All right, let's say if we came up with the same thing. For the first one, we're doing second sine of negative 0.8 gives us negative 53.1 degrees. For the next one, first, let's switch our mode to radians because they want the answer in radians. And then let's do second cosine of 0.4. And that's going to be 1.16. And for our units on this one, we are going to put radians. For our last two problems, let's see if we can find some values of inverse trig functions without a calculator. Now we want these answers in radians, and we can leave our answer in terms of pi, so that's going to help us with the no calculator thing. First thing I do on these is I look at my trig function, and I figure out which quadrants am I using. For inverse cosine, I remember I'm using the top half of the unit circle, and now I'm asking, since this is inverse cosine, where does the x value of the angle equal radical 2 over 2? So radical 2 over 2, I'm not sure exactly where it is or even what that decimal is because I don't have a calculator, but I know it's going to be somewhere in quadrant 1. Now why do I know it's in quadrant 1? Well, because the only other positive x values are in quadrant 4, and I'm not allowed to use quadrant 4 because I'm only allowed to use the top half of the unit circle. Now the other thing we have going for us on these problems, if they're going to make us do this without a calculator, they're only basically asking you to give them back special angles, because those are the only angles you could really be expected to memorize these values for. So cosine of what gives us back radical 2 over 2? Oh, cosine of 45. So 45 degrees then is our answer. They do want that in radians, so that'll be pi over 4 for our answer. And you don't actually have to write radians after it, because remember we said that if you give an angle with nothing after it and no other kind of symbols, we assume it's in radians. All right, pause the video, try this next one on your own. Which side of the unit circle are we using? For inverse tan and sine, we always use the right side of the unit circle. So you'll notice that quadrant 3 never gets used in any of this inverse trig stuff. So now we're asking, where does the slope, because this is tangent, where does the slope equal 0? Well, the slope of the terminal angle would equal 0 over here at 0 radians. It also would equal over here at pi, but again, we're only using the right half of the unit circle for this. So this answer then is going to be 0 radians, which is the same as 0 degrees. Either way, our answer on this is 0. So that's it for our first lesson on inverse trig functions. Join us for part 2. Until next time, this is Mr. Sutton signing off.